In this video, we're going to look at some of our multiple choice questions on our test review for part 2 of chapter 3. Question number 9, an object is moving along a line and it has the position function s of t is equal to 4 times t minus 3 squared. Which of the following statements is true? If I look at my choices here, I can see that these choices are asking me about when the object is moving in the positive direction, if it's moving positive and then negative. It's asking me about the direction of the object. And the best place to find direction is by finding velocity. So if my position function is 4 times t minus 3 squared, we can find velocity by taking the derivative. Now I'm going to do a derivative using the chain rule. And here we have 4 times something squared. And the something is t minus 3. So this first derivative would be 8 times something, and the derivative of t minus 3 is t. So my velocity function, which is the derivative of position, is equal to 8 times t minus 3. Oh my goodness, I did my derivative wrong. The derivative of t minus 3 is not t. It's 1. Okay, 8 times t minus 3 times 1. And so what we really end up with there is 8t minus 24. So I could think about this graphically. It might be the easiest way to think about it. 8t minus 24, it's going to cross, down here at negative 24, goes like that. The 0 here, we could set 8t minus 24 equal to 0. 8t equals 24 and t equals 3. So the 0 happens there at t equals 3. So let's see if we can figure out an answer now that we have this information. First option says the object moves in the positive direction for t greater than or equal to 0. Well, that's not true, because for this first part where t is greater than 0, my velocity graph is negative. It's below the x-axis, and so that means that we're moving in the negative direction. Answer B says the object initially moves in the positive direction. Again, that is not true. My velocity is negative. Answer C, the velocity initially moves in the negative direction. There we go. It stops. That happens right here at 3, where the velocity is 0. And then it moves in the positive direction. And that happens here. We are positive. And so that certainly seems to be the answer. Let's consider the other two. The object moves in the negative direction for all t greater than or equal to 0. That's not true, because it turns positive here after t equals 3. And then answer E says the path of the object is a parabola. And I know that answer may be tempting because the position function is a quadratic. But remember, they told us this object is moving along a line. It's just moving back and forth on a line. And so its path is not a parabola. And so therefore our answer is answer C. All right, question number 11. Find the slope of the line tangent to the curve xy cubed minus x cubed y equals 6. So I'm going to rewrite that curve down here. And since I see the x's and y's mixed up together in the curve, that means we're going to use implicit differentiation. And my first term is an x times a y, so I need to do product rule. So the x is going to be my f, the y is going to be g. My product rule starts out f prime times g, so the derivative of x is 1, and g is y cubed, plus g prime times f, so my g prime would be 3y squared dy dx. Don't forget that dy dx whenever you're taking a derivative of y. And this is g prime times f, which is x. All right, now I have another x times y. We've got to do product rule again here. So that's going to be f and g. And then another thing I'm going to do, since this is a minus, I'm going to change that to plus a negative. And I'm going to keep that negative in there with the x cubed as I do the product rule. So the product rule starts out f prime times g. So my f prime is going to be minus 3x squared times g, which is y, plus g prime dy dx times f, which is negative x cubed. And this is all equal to the derivative of 6, which is 0. All right, now at this point, we want to solve for dy dx because I'm trying to find the slope of the tangent line, which means I'm trying to find the derivative. So any term that has dy dx, those are going to stay over on this side. So that's that term and that term. The other terms I'm going to move to the other side. So I have 3y squared. Actually, let's put that x in there. 3xy squared dy dx, just moving this x up in there. And then I have minus x cubed dy dx. And this is going to be equal to negative y cubed. I'm so sorry, that's my dog. Negative y cubed plus 3x squared y. So my next step here is to factor out dy dx over here on the left. Dy dx times 3xy squared minus x cubed, still equal to negative y cubed plus 3x squared y. And finally I'm going to divide. All over 3xy squared minus x cubed. Okay, there we go. There's our derivative. And I want to know the slope of the line tangent to the curve at the point 1, 2. So I want the derivative at 1, 2. So I'm going to plug that in. I'm going to have to give myself a little room here. Let's erase some of the work. There we go. Keep my derivative though. All right. So dy dx evaluated at the point 1, 2 is equal to negative y cubed, so negative 2 cubed, plus 3 times x, which is 1 squared, times y, which is 2, over 3 times x, which is 1, times y, which is 2 squared, minus 1 cubed. And so that equals, on the top, it looks like I get negative 8 plus 6 over 2 squared is 4 times 3 is 12 minus 1. So that equals negative 2 over 11, which is answer C. All right, let's do one more question. Question number 12. If f of x equals inverse tangent of e to the negative x, then what does f prime equal? So we're looking for a derivative here. And I see that I have inverse tangent, not just of x, but of something, inverse tangent of something. And then that something is not just e to the x, but it's e to the negative x. So I've got to do a chain rule, and it's going to involve 3 pieces. So I have inverse tangent of something, and then I have e to the something, and then negative x. So my derivative rule for inverse tangent is 1 over 1 plus x squared, but instead of x, we're going to put something squared. The derivative of e to the something is e to the something, and the derivative of negative x is negative 1. And then this goes in here, negative x goes back in there, so I get 1 over 1 plus e to the negative x squared times e to the negative x times negative 1. Now if I look at my answer choices, none of those seem to match this. And so at this point we need to do a little simplifying. One thing that we can do, this e to the negative x, can be rewritten. Since that is a negative exponent, I can move that e to the denominator and just rewrite this as 1 over e to the x. And so that's what we're going to do. I'll keep the different colors. So I've got 1 over 1 plus, and let's see, I've got e to the negative x squared. When you have power to a power, you're going to multiply those powers. So this becomes e to the negative 2x. And I'm going to be multiplying this times 1 over e to the x. And then I still have that negative 1 out there. I'll just multiply that in right here, make that negative. So at this point, what we want to do is take this e to the x and multiply it times both terms in the denominator of the first rational expression. And I'm also going to multiply my numerators. 1 times negative 1 would be negative 1 over e to the x times 1 would be e to the x plus e to the x times e to the negative 2x. So here I'm multiplying like bases, which means I want to add my exponents. And negative 2x plus x gives me negative 1x. So I've got e to the negative x, or the negative 1x if you want to write that 1. And now if I look up at my answer choices, it looks like my answer here matches answer choice C.